graph the following equations in the Cartesian plane. Now, in the previous video, we took these three equations, we made tables for them, and we looked at their rates of change. Now I want to look at their graphs. And to do this, I will just quickly recap making a table for each one of them. So, for instance, if y equals x plus 3, when x is 0, y would be 3. When x is 1, y would be 1 plus 3 or 4. When x is 2, y would be 2 plus 3 or 5. If x is negative 1, then y equals negative 1 plus 3, which is 2. We can see that as the y's go up by 1, the x's go up by 1 as well. So, if we plot these points, negative 1, 2, that's here, 0, 3, 1, 4, and 2, 5. And we see that these points lie perfectly on a line. This is y equals x plus 3. Now, let's take a look at y equals negative 6x. If x is 0, y would be 0. If x is 1, y would be negative 6 times 1, or negative 6. If x is 2, y would be negative 6 times 2, or negative 12. If x is negative 1, y would be negative 6 times negative 1, or positive 6. We see that as the x's decrease by 6, as the y's decrease by 6, the x's go up by 1. Now, 0, 0 is here at the origin, 1, negative 6 here, 2, negative 12 would be slightly off the grid around here, and negative 1, 6 is here. Once again, our points lie perfectly on a line. This is y equals negative 6x. Finally, let's take a look at y equals 2/5 x plus 10. So, if we make ourselves a table, you may recall last time that we actually made our x's change by 5 so as to avoid getting fractions for y. If x is 0, 2/5 times 0 is 0. 0 plus 10 is 10. 2/5 times 5 is 2. 2 plus 10 is 12. That's already going to be off our grid, so I'll leave that alone. And negative 5 times 2/5 is negative 2. Negative 2 plus 10 is 8. So, negative 5, 8 would be here. 0, 10 here. And 5, 12 would be about here. And our graph would look something like this. Now, I want to take a look at these graphs and their equations and see what sorts of patterns we might find. Now, we've already discussed how the coefficient of the value of x gives the rate of change. So here, the rate of change is 1. Here it's negative 6, and here it's 2/5. Now, what's the significance of that rate of change to our graph? Well, let's take y equals x plus 1. The rate of change is 1. You'll notice in the graph that the graph goes up 1 and over 1 to get to each successive point. For the equation y equals the opposite of, or y equals negative 6x, the rate of change is negative 6, and as we go over 1, we go down 6 on the graph. And In the final equation, y equals 2/5 x plus 10, the rate of change is 2/5, and for this graph, as we go over 5, we go up 2. You'll also notice that the steepest of these graphs is the one with the rate of change which is largest in absolute value, -6. The least steep graph is the one that has the smallest rate of change in absolute value, 2/5. You'll also notice that two of the graphs from left to right increase, or go up. But the equation with the negative rate of change from left to right goes down. You'll also notice that the y-intercept of each graph appears in the equation. For instance, y equals 2/5 x plus 10. The y-intercept here is 10. That is where the graph crosses the y-axis. For the equation y equals x plus 3, it crosses the x-axis at 3. And the equation y equals -6x, which would be the same thing as y equals -6x plus 0, it crosses the x-axis at the origin. Let's take a moment and summarize. So the equations that we just looked at were in the form y equals mx plus b, where m was a constant and it corresponded to the rate of change. The rate of change tells us on the graph how much you go up and how much you go over, the change in the y over the change in the x. The significance of this constant, which I've called b, is that this is the y-intercept. This number tells us where the graph of the equation will cross the y-axis. This equation, y equals mx plus b, is what we call slope-intercept form of a line, because this equation, this form, tells us two pieces of information. Now, the word slope is really just the same thing as the rate of change. It's how steep the line is. And the intercept refers to the y-intercept. So y equals mx plus b is slope-intercept form, where the slope, or the steepness of the line, is the rate of change, and the y-intercept is this number here.